Hey, Alex here from Blacksheep IT Consulting. This is the third part of a video series on how to use the Oracle Cloud Infrastructure REST API from within Siebel OpenUI. So this is a quite lengthy series, and I encourage you, if you haven't done so already, to go and watch part 1 and 2 of this series. You will find the links in the description. So let's start this third part with a demo again. So you see on the screen service request list applet, and for each record we are displaying the sentiment of the summary. So the summary is the text here in this field. So has gone away while I'm clicking here. So let's select a few others and click that little green man button, which of course is a custom button. And after a while, we see the sentiment for these records is not good. So negative sentiment for most of them, while neutral for the second one. Let's try one more time. Let's go to the next set with some meaningful summaries. Click the button and you can see a few moments later, the sentiment analysis is done. So the sentiment analysis, of course, is an OCI AI service that we call through the OCI REST API. We get the results, and of course we display the results visually on the screen. And the second demo in this video, a use case of using the OCI infrastructure REST API is, for example, to upload attachments, let's say as base64, and have them analyzed. So this is a PDF attachment, apparently an invoice, but let's make sure, let's have OCI analyze it. So when I click the button, the document is sent as base64 to OCI. OCI does the analysis and comes back with the document type, the number of pages, the text, of course. It has extracted all the text. We can extract much more, but this is just a simple demo. So how do we do all this? Well, part of this is standard OpenUI extensibility. And for the sake of demo and simplicity, I'm using a single file approach. The OpenUI JavaScript file is called bcrm OCI adapter.js. You'll find the sample file with, of course, the cautionary introduction that it is just an educational sample and you should not use it at your own peril in any other environment than just for your personal learning experience. So we are at the bottom of the file where we have a listener for the post load event. So it's registered with the application common platform OpenUI manifest object. So the file is loaded whenever Siebel loads, and this listener now is established when the view has finished rendering. So here's the function that is invoked. The function is quite simple. It gets the applet map, and then for each applet gets the presentation model and calls a function to add the button that we have seen, the little green man button. So that function, of course, has the details what happens when you click the button, so it's quite interesting. So here's the main function. So it gets the PM, so we can use the PM to get all the important confirmation. There is a bcrm OCI config object in the same file, which carries some default values. Let's quickly check it out. It's on top of the file. And so these are values that you have seen in other videos, values that are necessary to make the calls to OCI or to the Siebel REST API. So it retrieves that as a variable, so you can use it. And we get the usual suspects from the PM, the applet's full ID, the business component name, the raw record set. And at the moment, the demo only supports list applets, so we rule out any other applet type by checking on the special list applet property, get list of columns. in the presentation model. If that's not defined, nothing happens really. So if that's defined, it's a list applet, and off we go. We check if the configuration contains the business component. Actually, made a little bit of a mistake first, because that configuration object for this part is this one. And so this means that you list the business objects here with the list of fields you want to support. Notice that action, service request, and action attachments are listed. So any applet not having one of these business components will not show the button. And the button will only work if the record set has one of these fields in the array. So this is just a filter mechanism, really. Okay, having gotten that out of the way, so we basically get the field list now that we have seen in that configuration file. And here we check if, well, either there is no records or the list of fields does not contain the field. So only if that's not the case, we carry on. We get the applet element, the DOM element. We add a method for good measure. So when any method is invoked on the applet, we actually remove the container for the icons, which we create on the button click, but it could be there. So that's a cleanup step if there is any. Now let's find the buttons array for the applet and create an ID for the button. Must be unique because it could be multiple applets in the same view. And so we check if that buttons array has been found on the applet, and we check if there's no custom button at the moment. So there's no custom button, we create it. So here's the little green man that you have seen. And we create a click handler on the button to, well, again, remove all icons that are there from recent calls. We get the raw record set, the current record set of the applet as it shows the 10 records or 20 records. A special treatment for attachments here, so let's skip that. What happens when you do it in a regular list applet? It gets a body for the post request, so it prepares the language payload. So this is of course just an example, but we pass the record set and the first field in the list, so it just works for the first field in this demo. We pass that to a function which prepares the payload for the OCI request. Okay, let's check out that function. So again, the function gets the record set of the current applet. It gets the field name, one field name that is. And so a language payload for OCI has basically an array of documents. And each document has a key, a text in the language code. So now we can just, well, go through the record set, which we do here, and create a new item, a new document, so to speak, and set the key. So we're using the row ID of the record as good as any key, of course, plus the field name. Then we set the text, retrieving the value of that field, let's say the description field, and then we're hard coding the language code to English here. The demo doesn't support multiple languages, but that shouldn't be an issue for the demo. And we just push that new item to the documents array, and then the entire body is returned. Okay, so that's now here. And then we can start invoking the OCI AI REST API. And I've created a wrapper function to receive a type of service that you want to use, like the language service, the type of action that you want to use. That's the documented actions from Oracle, like batch detect language sentiments. Some actions have additional query parameters, like this one, level equals sentence. And of course, we must pass the body for the post request. So this is the main function that, of course, is truly interesting here. So let's check it out. So this one reads the BCRM OCI defaults, so the big defaults that we have already discussed, because well, needs to resolve a few things and add a few things. I noticed during my experiments that the version part of the URL is very important. So I have a default version, but some services have a higher version. So for example, for vision or document understanding, well, I just use the version from the current Oracle documentation. Might change in the future. So preparing the URL here is, of course, the protocol, then /service. So that translates to, for example, language.ai service. Then you have the region, which again, you need to pass in. So my region is EU Frankfurt 1. Then you have the domain, which is, well, oci.oraclecloud.com. So that's the host part of the URL. So you can see an example here, followed by the version, /actions, and then the action itself. So here we are all concatenating this and adding the query if there is any. And a little bit different for the document understanding service, doesn't require an action or actions in the URL. And if there is the PII entities is used as an action, we add a masking instruction. And if the batch language translation, we add the target language code, which is defaulted again in the configuration options. So you see the options here. And of course, your mileage might vary a lot if you prepare these URLs. So now we have the URL for the post request we want to send to OCI. But remember the second video, make sure you watch it. OCI requests need to have a signature which is derived from portions of the request itself. So we need to pass that request through a special function to calculate the signature. The payload is, of course, the body that we have generated. And we also pass the action because we need to, well, process the data differently depending on the action. So this adapter function is basically the first, doing the first part. It makes a request to the Siebel REST API, not OCI, for a custom business service. And that's the custom business service we discuss in great length in part 2 of this video series. So I'm not going into details here. Basically, that business service is a Java business service that takes the request information and calculates that signature. So we can now call the real OCI request because the result of the Siebel business service is the correct signature information. We still pass on the payload, the URL, and the action. And this is the method which then makes contact with OCI. So you can see that the most important part we retrieve is the signature, that calculated string that we have discussed. And here's a little bit of replacement going on because the signature calculated by the business service using a third-party library does not include the version. The version is not required, but I just include it for good measure. And now for the post request, we set all the required headers. That is content length, x-content-sha256, all calculated by the custom business service. X-date, we have discussed why we don't use date, so X-date seems to do the trick most of the time. The magic signature as the authorization header, the accept header, the host header, and the content type header. So all these headers are required for a post request to OCI. And here's the fetch. So that is, of course, a asynchronous fetch. So we wait for the results to come in, a little bit of logging here, and then we can process. So whenever OCI comes back, we process the OCI data using, well, of course, the result, the response of OCI, and the action. So there's a wrapper function to be invoked whenever OCI is returning data. And let's check out that function. So here the function, gets its bearings, gets the active applet because we just click the button, should still be active, and gets the usual suspect from the PM, and now switches for the action. So analyze document is the attachment thing, and the language sentiment thing is down here. Language sentiments display as icons, so I've just used a simple map to map the scores that OCI returns to a little emoji icon. Of course, that's a very easy way, a little bit cheap maybe, but it does the trick for the demo. Then we get the documents array back from the results. Create a container, format it a little bit, so that's the icon overlay, so to speak, that you have seen in the demo. And now we parse the results, which are in the same order as input, so it's basically record by record now. Get the key. We actually don't need row ID or field, but that's fine. And retrieve the sentiment. So for each document, OCI returns the calculated sentiment. And now we can create our icon. It's a div with a span inside. We calculate the icon height as of the table row height in the list applet. We set the text of the span element to the map result. So this is where the icon becomes the text, or the text becomes the icon. How do you say that? And an attribute for good manner, so that you hover, when you hover, you can see a text. And we append that to the container, and once the loop is over, we find a suitable div in the applet and add the container, which is the 10 little icons in a row. So you can see that this function takes care of all the actions that we're using. So if you look at the analyze document action, see that of course is very different input. We get the pages information, the page count, the doc types, the lines, and we simply concatenate some HTML with it and display it as a dialog. So it's very, very simplistic. You can do a lot more with the information you gather from OCI AI services, of course. But it does the trick of conveying the fact that you can pass stuff from Siebel to OCI using the REST API, bypassing any Java SDK that you might not want to use, and parse the results in the browser. Of course, it's easier to work with JSON in the browser, but you can also imagine to use, for example, an outbound REST service, which you would have to create manually. There's, to my knowledge, there's no file, no Swagger file for the OCI services right of now. But you could also use EI HTTP requests. If you want to pass that processing power down to the Siebel server or an EI object manager, you can do it. The processor jobs is for the document understanding API, which actually produces documents and puts them in a bucket on Oracle Object Storage, and that bucket is then opened. So that's a demo I haven't shown. So, armed with the knowledge how the OpenUI part is implemented, let's see the demo one more time, in first just by clicking the button, this time on the activities list applet. So uses the comments and to calculate the sentiment here. So this is positive, is negative. And now let's see it in slow motion using the debugger. So I've set my breakpoint right in the click event handler on the little green man button. So let's click it, and of course stops at the breakpoint. So now we can go through the code in slow motion. And so get the record set, and here it's actually for language payload. So let's see, let's just run this function here, and this is a valid payload for language AI. So an array of documents, each one has a unique key and a text. So as you can see, that's the text of those comments field of all the 10 records in the current record set. All right, so let's jump into the invoke OCI method. So retrieve the version number, calculate the URL. So here's our complete URL for that action in the language AI service. And nothing else to do than to pass it on to the OCI adapter. Let's jump in here. So getting the headers. So that's for the Siebel REST API. So that's just a call to the Siebel REST API. But we're preparing the input property set. It's a business service call. So the business service, as displayed in the second part of this video series, retrieves the entire body for the future post request. The method is of course post, and the URL and the configuration file path, which could be of course coded on the Siebel server side, doesn't need to be on the browser script side. So that is now stringified, so it can be passed on to Siebel, and here's the fetch doing the Siebel request. So let's set a breakpoint here, and now the results are in, so the business service of Siebel has responded. Let's see if we can review this. So it has calculated the signature. So now actually we have 5 minutes. That's the supported offset of the timestamp to send the request. There's the well-formatted date as Oracle expected. We have the content length, that's the post, the body, and that's the hashed and base 64 body. That again, these things have been discussed in great length in part 2 of this series. We also have extracted the host and the path. So that's what we get back from the Siebel Business Service and can now do the real OCI request. So let's jump in and getting that magic signature. It's all about that signature here. Fixing up the signature with the version, and now see the output property set of the business service now is used to set all these headers, especially the authorization header, and all that goes into the request options. And now we are about to fetch the URL. Again, we can put a placeholder here. And the results are in, back from OCI. And let's see those results. So Oracle returns a document array with the key for each document, and you can see the scores, the overall score, which is what I displayed. There are even the scores for the other sentiments. So it's, it's a little bit more, it's 50% confident, it's negative. So that's an overall negative score. Yeah. So that's how you read that. And that's for each record in the current list applet. So now we have only one thing to do. We have to process that data. So let's jump into the process function. So getting the active applet information, jump to the correct action, so that's language sentiments, getting the current height of the table rows, calculating that little map, getting the documents, so that's the array of documents here, create the container, iterate the documents. So let's do the first one, getting the key. Oh, we can, because we have stored the row ID in the key, we can use that. The demo is not using the row ID, would be clever to use it. Read the sentiment, that's the first row, generate the icon, and append the icon to the container. So that of course runs 10 times. So now let's jump out of the for loop, and now all we have to do is append the container to the applet, which should just happen now. Right, and there you go, there you have it. Okay, so that was a walkthrough of the third and final part of our little demonstration to use the OCI REST API in Siebel's CRM to invoke any kind of API services that you want to use, not restricted to anything, not using the Java SDK, just the plain REST API. Thanks much for watching, take care, and bye-bye.